Hello students, welcome back into my channel. In this video, I'm going to show you how we find the solutions of a past paper. Past paper for those international AS and A-level students. Mathematics paper 4 mechanics. October-November 2023, 970941. Right, let's start with number 1. A particle of mass 1.6 kg is projected with a speed of 20 meters per second up a line of greater slope of a smooth plane inclined at alpha to the horizontal, where tangent alpha equals 3/4. It is we have to find sine alpha and cosine alpha, but later. Use an energy method to find the distance the particle moves up. Okay, the particles move up or the object moves up the plane before move up the plane before coming to instantaneous rest. Okay. Firstly, I'm going uh, to sketch the situation. This is the particle according to this information before it stop here according to this words that it will be instantaneous rest. So if the particle here and it will be stop here, it means this particle moves as long as x, separate x. Okay. And alpha here. Okay. This is angle alpha. According to this information that smooth plane incline at alpha to the horizontal. Okay. So on this particle actually acting, this is force to upwards and as well there is, I'm going to draw all forces acting on this object. Okay. This another force, and then this is mg sine alpha. Okay. Okay. This is mg, m times g, and this right line is mg cosine alpha. So this side for mg cosine alpha and this side for mg sine alpha. Right. So again, this object or this particle will move as long as x. And we are going to find distance, or we are going to find x if distance. Right. Tangent alpha equals 3/4. If tangent alpha 3/4, we are going to determine sine alpha. Tangent alpha, it means 3 here, 4 here. So this side is 25, 5, because 9 plus 16. So it is the slope is 5. Okay. So now this one, we have to find that force acting on this particle is moving to this position until it becomes instantaneous rest. It will be, it means it will stop here. So when it moves from this initial point to the final point, it needs it needs mg, the force mg sine alpha, okay, times x. That's the force acting on this object. And as well, it needs kinetic energy. Okay, kinetic energy. Kinetic energy is half mv squared. So m is how much m? 1.6. Okay, times g 10 sin alpha, sin alpha equals 3/5. So times 3/5 times distance, it's going to be 16 times 3/5 times x times 1.6, because mass and velocity or speed 20 meters per second. 20 squared. 48/5 times x, it becomes 400 times half, 200, 1.6. So x equals 200 times, I'm going to calculate first, 200 times 1.6 equals 3. Okay, 320. Over 45, 48/5. So it becomes 320 times 5 over 48. So the result is 33.33. And the unit is meters because distance. So this is the distance. Number 2, a particle of mass 2.4 kg is held in equilibrium by two like inextensible strings. These are the strings, one of which is attached to point A and other attached to point B. This point A and point B. The strings make angles of 35 and 40 degrees with the horizontal sheet diagram. Find the tension in each of the two strings. Okay, we are going to find the tensions that these strings attached on point A, while this one, the string attached on point B. And these are two tension 1 and tension 2. Now I'm going to show you that all forces acting on this particle. Firstly, this force to downwards, weight equals 2.4 times 10, m times g equals 24 newtons. And secondly, I'm going to find two forces acting on this particle, two forces to upwards, vertically upwards. Firstly, this force to upwards, and how we determine this force. I'm going to create this the triangle here. Okay, if this is A and this is B, it's T1 sine 35 equals A over T1. So A equals T1 sine 35. So this force is T1 sine 35. How about this? Okay, B cosine 35 equals B over T1. With the same procedure, we can state here that this force to the left is T1 cosine 35. And this force is T2 sine 40. And this force to the right is T2 cosine 40. So, therefore, we can create a straight line to upward that there are two forces acting on this vertically upwards. This is T2 sine 40, this one, and this is T1 sine 35, this one. So we can state that all forces acting horizontally okay, and at the left, all forces acting vertically. Okay. All forces acting horizontally are T1 cosine 35 and T2 cosine 40. So we can state that T1 cosine 35 equals T2 cosine 40. So T1 equals T2 cosine 40 over cosine 35 or cosine 40 over cosine 35 times T2. Now, forces acting vertically, all forces acting vertically are T1 sine 35 and T2 sine 40 as well, two downwards. T1 T1 sine 35 plus T2 sine 40 equals 24 Newton. Okay, 24 newtons to downward. T1 sine 35 plus T2 sine 42 upwards. T1 equals this. Cosine 40 over cosine 35 times T2. So we will substitute T1 into here. It becomes cosine 40 over cosine 35 times, okay, T2 times sine 35. Plus T2 sine 40 equals 24 newtons. I'm going to separate this. So it becomes cosine 40 times sine 35. Over cosine 35. T2 plus T2 sine 40. 24 newtons. And factorize. T2 times cosine 40 sine 35 cosine 35 plus sine 40 equals 24 newtons. I'm going to find cosine 40 times sine 35 over cosine 35 through calculator. This is the number 0.536 plus sine 40 0.643 24 newtons. T2 equals 24 newtons. So 0.536 plus 0.643 is 1.179. And it is 20.36 newtons. We're going to find T1. So tension 2 is 20.36 newtons. We're going to find tension 1. Tension 1. Based on this formula, cosine 40 over cosine 35. Cosine 40 is through calculator with 0.766 over calculator 0.819 times T2. T2, this one, 20.36. Calculate T1 equals 19.1 0.04 newtons. So the result is T1 equals 19.04 newtons, while T2 equals 20.36 newtons. Right. Number 3. The diagram shows the velocity time graph for the motions of a bus. The bus starts from rest and accelerates uniformly for 8 seconds until it reaches a speed of 12.6 meters per second. The bus maintains this speed for 40 seconds. It then decelerates uniformly in 2 stages. Between 48 and 62 seconds, the bus decelerates at a meter per second square, and between 62 and 70 seconds, it decelerates at to a meter per second square until coming to rest. So coming to rest here on this point, right? Find the distance covered by the bus in the first 8 seconds. In the first 8 seconds, so the bus from the initial point until here until 12.6 here meter per second, as long as 8 seconds. So we are going to calculate this area triangle. So A, at distance, equals half times base is 8 and height is 12.6. So 8 times 12.6. I'm going to calculate 50.4 meters. So the distance from this point, origin to here, is 50.4 meters. Okay. Find the value of A. All right. Right. The speed until here is 12.6. Okay. As well until here 12.6. So the speed here, the speed equals 12.6. As well here, the speed is 12.6. And now decelerate from 12.6 being this one we are going to find. That 12.6 minus 8 times 14. This is speed. Why? These calculations based on the formula that v velocity equals initial velocity plus 8 times t. Okay. Yes. Why 14? Because 62 minus 48 is 14. 14, so it is 12.6 minus 14a. Next, this speed until here decelerates. Speed equals 12.6 minus 14a, okay, plus minus 2a times 8. Yeah, and it is 0. Okay, if speed equals 0. Let's calculate on this area. That's 0.6 minus 14a plus minus 2a times 8 equals 0. Okay, right. This part from this one, is the initial velocity of this part, the speed. Okay, and a because of this is negative 2a. Okay, right. Now we are going to find 10a minus 16a equals 0. So 12.6 minus 30a equals 0. So 30a equals 12.6. A equals 12.6 over 30. 0.42 meter per second squared because acceleration. Next, find the average speed of the bus for the whole journey. Right. Just now D1 we calculate already equals D1 is 50.4. Okay. The second distance is 40 times, yeah, from 8 to 48 times 12.6. How much is this? 504. Distance 3, a triangle 14, okay, times, oh, this not triangle, trapezium. This is 12.6 and this is 6.72. Okay. Why 6.72? Because 12.6 minus 14. I'm going to write on here. P3 because, yeah, 12.6 minus 14 times 0.42. So it's going to be 6.72. So that's why here, this entry is half times 12.6 plus 6.72 times, wait, mistaken, 14. Yeah, 14. Times 14. It is, I will calculate with my calculator, 135.24. Next, distance 4. The shape is triangle. Triangle with the base is 70 minus 62. 8. Half times 8 times 6.72. Okay. 6.72 times 8. 26.88. So total distance 50.4 plus 504 plus 135.24 plus 26.88 calculator 716.52 meters. Next, total time. Total time. Total time from 0 to 70. It means 70 seconds. So average speed equals total distance over total time. $716.52 meters over 70 seconds. It is 10.236 meters per second. Number 5. The diagram shows a particle A of mass 1.2 kg, which lies on a plane inclined at an angle of 40 degrees to the horizontal, and a particle B of mass 1.6 kg, which lies on a plane inclined at an angle of 50 degrees to the horizontal. So this is the particle B and this one particle A with angle, particle B angle 50 and particle A angle 40 to the horizontally straight line. And meanwhile, mass of B 1.6 kg, mass of A 1.2 kg. Right. The particles are connected by a like inextensible string, which passes over a small smooth poly P fixed at the top of the planes, span P. The part AP and BP of the string are taut and parallel to lines of greater slope of the respective planes. The two planes are rough with the same coefficients of friction mu between the particles and the planes. So the coefficient of frictions of this part and this part is same, right? Question. Find the value of mu for which the system is in limiting equilibrium. Okay. So now I will explain all forces acting on this particle A and B. Firstly, this particle. Firstly, string T, TA or T, and secondly, here T, P or T. Okay, and this are force as well, and resultant. So that if I will create this straight line to downwards as the weight is 1.2 times 10, 12 newtons. Okay. Then I'm going to create a triangle. Of course, 40 here. If 40 here, angle 40 here, it means this side is side of 12 sine 40. So it means this force as well is 12 sine 40. So what this side? This side is side of 12 cosine 40. And next this one. There's a force as well acting on this particle. Resultant. And next, this is weight 16 newtons. So 1.6 times 10. And this is 50, so it means this side is 16 sine 50, and this side is 16 cosine 50. This force as well, 16 sine 50. Okay. So now look on B first of all. On B, on particle B, that 16 that 16 sine 50 minus tension and minus FB equals 0. So, or tensions plus force on B, acting on B equals 16 sine 50. So we can write down like this, 16 sine 50 minus T minus force acting on B equals 0. Or tension equals tension 16 sine 50 minus FB. Okay, that's on particle B. On particle A, on A, this, that tension minus force acting on A minus 12 sine 40, it is 0. Or tension equals FA plus 12 sine 40. Resultant A, okay, this is resultant A, and this is resultant B. Resultant A equals 12 cosine 40. Meanwhile, FA equals 12 cosine 40 times coefficient of friction times mu. As well here, resultant B, 16 cosine 50, and force acting on B equals 16 cosine 50 times mu. Okay. So if RB and FB like this, it means this equation T equals 16 sine 50 minus B being 16 FB, I mean, yeah, sine 50 minus this one, 16 cosine 50 times mu. As well, this equation T equals FA plus 12 sine 40 being FA equals 12 cosine 40 times mu plus 12 sine 40. T equals T. So it means these expressions equals these expressions. Sine 50 minus 16 cosine 50 times mu equals 12 cosine 40 times mu plus 12 sine 40. Now regrouping, yeah. 12 cosine 40, this one minus 16 cosine 50 mu moving to the right side, join with 12 cosine 40, and it becomes 12 cosine 40 mu plus 16 cosine 50 mu, okay, equals 16 cosine 50 minus 12 sine 40. Okay, factorize mu times 12 cosine 40 plus 16 cosine 50 equals 16 cosine 50 minus 12 sine 40. It means mu equals 16 cosine 50 minus 12 sine 40 over 12 cosine 40 plus 16 cosine 50. So 16 times cosine 50 through calculator, 0.677 minus 12 sine 40, 0.643 over 12 times cosine 40, 0.643 minus 16 cosine 50, 0.766. And if you calculate and divide it, the result is 0.233. 233. Number 6, a car of mass 1,300 kg is moving on a striped road. A, on a horizontal sections of the road, the car has a constant speed 30 meters per second, and there is a constant force 650 newtons resisting the motion. Question: calculate in kilowatts the power developed by the engine of the car. Okay. So power equals force times velocity. Force is this one, 650 newtons. Meanwhile, velocity, 30. Calculate. It is 19,500 watts, or convert to kilowatts divided by 1,000, 19.5 kilowatts. Given that this power is suddenly increased by 9 kilowatts, find the instantaneous accelerations of the car. So we're going to find the instantaneous acceleration. P equals if power suddenly increased being 9 kilowatts, it means total P or total power equals 19.5 plus 9 kilowatts being 28.5 kilowatts. Okay, as you know that delta F equals M times A based on uh, Newton laws, Newton second laws, and then delta F equals 1300 A because M equals 1300. P is F times V, force times velocity. So if F the subject, this formula being F equals P over V, power over velocity. Or F equals power is 20,500 watts over velocity 30 meter per second, and it is 950 newtons, of course. So delta F equals 950 newtons minus 650 newtons. Based on the question here. Okay, this one. Constant force. So it is 300 newtons. This is delta F, delta F. So delta F equals delta F. It means 1300 A equals 300 newtons. So it is A 300 over 1300. 3 over 13, 0.231 meter per second squared because acceleration. Acceleration unit is meter per second squared. B. On a section of the road inclined at sine power negative 1, 0.08. So sine theta is 0.08 to the horizontal. The resistance to the motion of the car is 1000 plus 20 v. This is velocity, newtons. When the speed of the car is v meter per second, the car travels downwards along the sections of the road at constant speed with the engine working at 11.5 kilowatts. This power. So I will sketch this condition around like this. If this is the car and there is several force acting on this car. Firstly is W, the weight equals M times G, and then frictional force. After that, the resultant, this is normal, is mg cosine mg cosine theta, if this is theta, and 2 downwards, mg sine theta. Sine theta is this one, 0.08. So Fr, the resistance, force resistance is 1000, this one plus 20, velocity, newtons. Mass equals 1300 kg, and mg sine theta equals 1300 kg times 10 times 0.08. 1040, and then delta F equals 11,500 over velocity on this one. As you know that power equals F times V, force times velocity. So if F, the subject, P over velocity for this one. Now look, all the force acting on this object on this car, that delta F plus mg sine theta equals F R. So FR to upwards, and then this one to downwards. Right. So you're going to find these expressions to downward and these expressions to upwards. The force to upwards and the force to downwards. Delta F equals this one, 11,500 over 4 plus 1040 equals FR, this one, 1000 plus 20 V. So we have to set this equation becomes 11,500 over V minus 20 V equals 1000 minus 1040. Multiply by V, it becomes 11,500 minus 20 V squared equals 40 minus 40 V. Then it's gonna be 20 V squared minus 40 V minus 11,500 equals 0. Divided by 20, it is, yeah, it becomes V squared, and then 2V divided by 20. This is 575 equals 0. Factorize V, minus 25 and plus 23. So phi equals 25 or phi equals minus 23. This is not the solutions, but the solutions are this one. So velocity or speed equals 25 meter per second. Number 7, a particle moves in a straight line starting from a point O before coming to instantaneous rest at a point X. At time t-second after leaving O, the velocity v meter per second of the particle is given by this function v equals 7.2 t squared when the interval 0 to 2 seconds. V equals 30.6 minus 0.9 t when the interval 2 to 8 seconds. And the function v will be 1600 over t squared plus kt when t greater than 8, where k is constant. It is given that there is no instantaneous change in velocity at t equals 8. Find the distance of x. Right, the first step I will sketch this function, and then we are going to find the area under the graph and calculate the accumulations of area, and that is the distance, right? The first function is v equals 7 2t squared, 0 to 2. So I will begin from 0, t equals 0. If t equals 0, v will be 7.2 times 0. 0, 0 equals 2. V will be 7.2 times 4. 28.8. And if we sketch, this is v axis and this is t axis. The origin here. And if 28.8 around here and 2 around here, so the graph will be like this. It's semi-parabolic. Right. And the second function, phi equals 30.6 minus 0.9 t. I'm going to find t from 2. So phi equals 30.6 minus 0.9 times 2. It is 28.8. Same here. So it's starting from here. If t equals 8, the interval 2 to 8, 30.6 minus 0.9 times 8, 23.4. It's 23.4 around here. Wait, I'm going to use another color. And 8, for example, here. So the coordinate point here, the coordinate point 8, comma 23.4. We can create a straight line because the graph is straight line. This graph. Right. And the third function, that one, phi equals 1600 over t squared plus kt. This one. This is the first graph, the second graph, and this is the third graph. So I will start from this point. We will continue from uh, this coordinate point. If we continue from this coordinate point, it means phi equals 23.4. Let phi equals 23.4. If phi equals 23.4, it means t equals 8. So we are going to use this coordinate point 8, comma 23.4. So this equation will be 1600 over t squared plus x squared, I mean, plus 8k, 23.4. So 1000 over 64, 25 plus 8k, 23.4. So 8k equals 23.4 minus 25. 8k equals minus 1.6. So k minus 1.6 over 8 minus 0.2. Next, let phi equals 0 because we are going to find the intercept point with t here. We are going to find how much here. So if equals 0, this equation will be 1600 over t squared minus 0.2 t equals 0. Then multiply by p squared, 1600, 0.2 t cubed equals 0. And 0.2 t cubed equals 1600. The cube equals 1600 over 0.2. It is 8,000. So t equals cube root of 8,000, it is 20. So t equals 20. So on t-axis, this is 20. So the graph will be like this. If you sketch the graph, will be like this, the graph. Right. So now we are going to find the area. Okay. And then, yeah, this is the, I will start to calculate this area first. After that, the black area. After that, this area. The second area, and the third area, this one. Okay, first area. The first area, integral 0 to 2 of 7.2 t squared dt is 0 to 2, and the integrations of this 7.2 t squared t 7.2 over 3 t t power 3, and then after that substitute 2 and 0. But 7.2 is 2.4, so 2.4 times 2 cube minus 0 cube. 2.4 times 8, 19.2. I have to calculate first with my calculator. The second area, or area 2, from 2 to 8, yeah. So this is the first area, and this is the second area. The first area, this is the second area, this is the third area. Okay, so just now we already calculate this area, the first area. Now the second area from 2 to 8, and after that from 8 to 20. The second area, the function is 30.6 minus 0.9 t dt. And this integration 30.6 t minus 0.9 over 2 t squared, or 0, or yeah, oh wait, I'm going to simplify it, or like becomes like this. I will simplify 0.9 over 2 being 0.45 t squared. The last substitute 8 and 2. It will be 30.6 times 8 minus 0.45 times 8 squared minus 30.6 times 2 minus 0.45 times 2 squared. If 30.6 times 8, it is 244.8 minus 64 times 0.45, 28.8 minus, now this one, 2 times 30.6, 61.2, and this one, 4 times 0.45, I will calculate first, 1.8, that's one, 244 minus 8, minus 244.8 minus 28.8, to 16 minus this one, 59.4, and the result 156.6. Next, the third area, from 8 to 20. 8 to 20, so the function 1600 over t squared. Wait, I forgot. Plus kt, yeah, plus kt. It's fun. And plus kt and k equals minus 0.2. Right. T dt. And the integration will be minus 1. It means minus 1600 t power negative 1 minus 0.2 over 2 t squared. Now substitute 20 and 8 will be minus 1600 times 1 over 20, then minus, that's 0.1 here, 0.1 times 20 squared. And next, 1600 times 1 over 8 minus 0.1 times 8 squared. Okay. 8 is divided 80. Okay. Minus 80 minus, this is 400. 0.1, it means 40. Minus, this is, of course, minus 200. Minus 64 times 0.1, 6.4. Minus 120 minus, of course, this is 206.4 plus 206.4 is 86.4. So distance is the accumulations of all area. Uh, First area 19.2 plus second area is 156.6, and the third area 86.4. So this is 262.2 meters. All right, thank you students for joining with me in this lesson. See you.